Hello, welcome back to the chapter 4.3 videos. This lesson is all about some applications with systems of equations. So we're just going to jump in. So it says the sum of two numbers is 32. One of the numbers is 4 less than 5 times the other number. Find the two numbers. That can be a little overwhelming. So let's break it down. We have two numbers. I'm going to call them X and Y. And it says the sum. So that means we're adding. So when we add them, we get 32. So we have limitless options, right? 0 plus 16, 16 plus 0. It doesn't say if they could be maybe negative. So we have to have some other kind of what are we going to say, characteristic that we know about the two numbers or relationship between them that can help us narrow down what two numbers they are. So it says one of the numbers, we'll say X, is, so it's equal to 4 less, so it's 4 less than 5 times the other. Okay. One of the numbers is, so I'm going to say X is, I'm going to call that other one of the numbers X, is 4 less than. So it's 4 less than. We have to subtract 4 from the 5 times the other number. Okay, because I know exactly how to make X, I'm going to use the substitution method. So I'm going to substitute this in for X into the first equation. So 5y minus 4 is going to go in for X plus y equals 32. So notice that for X here, I just replaced 5y minus 4. So now I have 5y plus y as 6y minus 4 equals 32. If I add 4 to both sides, we get 6y equals 36. And dividing by 6, we get 6. So now I can put what I know about y into this equation. So x equals 5 times 6, if that's what y is. And I get x equals 30 minus 4, or x equals 26. So my ordered pair is 26 and 6. And yes, they do add to 32. Okay. The larger of two numbers is more than twice smaller. So it sounds like I have two numbers, X and Y. It says the larger of the two. So I'm going to say X is the larger. So the larger of the two is, that tells me equals 5 more than. So I'm adding 5 to something. I'm adding 5 to 5 more than twice the smaller. So 2 times Y, because Y is the smaller. If the smaller, okay, Y is subtracted from the larger, so X minus Y, the result is 12. Find the two numbers. Okay, I'm going to substitute 5 plus 2y in for X. So 5 plus 2y minus y equals 12. 5 plus y equals 12. And I come and so subtracting 5, I get y equals 7. And then I can put that back into the first one. So x equals 5 plus 2 times 7. So x is 5 plus 14, and x is 19. So I have the ordered pair 19 and 7. And the difference between them is 12. Okay. So, example 3. If tickets for a host, if tickets for a show, oops, I'm missing the S, show cost $2 for adults, and we need a dollar sign, and $1.50 for children, how many of each kind of ticket were sold if a total of 300 tickets were sold for $525? So This is, we have two equations. One is the number of tickets. That's kind of what we're talking about, right? And I'm going to call them children and adults. And I know that if you add them, I sold 300 tickets. The other equation I'm going to call my value in dollars equation. And so I'm going to put a value to the tickets. So the tickets for the children is $1.50 for the children's for each children ticket and $2 for each adult ticket. And it says that that value is $525. So now I have a system of equations, and the way they're lined up, I can actually do substitution quite nicely. I am going to multiply row 1 here by a -2 to eliminate A. So a -2 times row 1 gives me a -2C minus 2A equals a -600. Then I'm going to leave row 2 as is. So 150C plus 2A equals 525. So my A's cancel out. And I'm left with a -50 cents C equals a -$75. And so if I divide by a -0.5, I get 150. So I must have 150 children. And so if I had 150 children, and there were 300 tickets total, that means I must have had 150 adults as well. $150 adults and 150 children. Touch me back for the second part to lesson 4.3. There'll be questions 4, 5, and 6.